Okay, party people. My name is Nick Gaske. I am a contributor to the Fabric documentation and the Fabric samples, and today we are going to look at how to reconfigure an application channel, meaning we're going to add a new organization to it. Okay, so this is an extension of the build your first network scenario. So on my screen here I have 3 terminals, and inside this directory I have all the common stuff that you'd expect to see in BYFN. In addition to that, you'll notice that we have a new Docker Compose for our org3, and this is going to start 2 peers for that new org and a CLI container specific to that org. And then we have this org3 artifacts directory, of which 2 files are of interest. We have a crypto-config YAML file right here, and then we have a configuration transaction YAML, and that should be self-explanatory. We'll leverage this guy right here to print out the org3 specific JSON material, and then we'll use this guy to get all the keys and certs. Okay, so first things first, let's spin up the normal BYFN scenario. Okay, and this is all covered in the documentation, and if you're watching this, chances are you've gone through this before. So we'll spin this network up with the default settings of my channel and the 10,000 second timeout. Then down here, we'll do a little work while all that stuff is running in the background. So we're going to go into that new directory, the org3 artifacts, and we're going to use that crypto-config YAML. So I have all my commands posted over here. So first, we'll generate the crypto material, and this will propagate up to the CLI container when we need to form this update object. Okay, so that was the org3 crypto material, and this is really the update material that we need here. Okay, and if we look at these commands, they should be self-explanatory. We're going back 2 directories to the binaries. We're going to use this tool. We're looking at that new config.tx.yaml, and we're going to print out the org3 MSP material, pop it into a channel artifacts folder, and call it org3.json. Okay, so now we should have some crypto material for this new org, which we can see right here. Okay, pure organizations. If we hop back to the root of our directory and go into channel artifacts, we should see that JSON that we just created. Okay, great. Now the last thing we need to do is we need to pop the orderer material, the ordering certificate material, over to this other crypto directory. We use that orderer TLS CA cert to verify the handshake on when we're fetching config blocks or when we're posting stuff to the ordering service or even on invocations. Okay, so we've done our little bit of housekeeping. We've created the keys and certs. We've created a JSON object which we're going to use to modify the configuration, and we have popped over the orderer MSP material into our new crypto config directory. Okay, so this guy finished successfully. We can hop out of there, and now let's leverage the CLI container that we got for free with this. Okay, and remember, this guy right here, this CLI container, is bootstrapped with the Peer 0 org1 MSP material and environment variables. So it's acting on behalf of that peer for org1. So whenever we need it to target a different peer or sign with a different identity, we're going to have to throw some environment variables in to overwrite its configured settings. Okay? So let's see what the instructions say. So we're going to install this JQ tool, and that's going to let us manipulate our JSON objects a little better. So we do this apt update, and then apt install JQ inside of the CLI container. Okay, great. Now we need to fetch the configuration block. Or before we do that, excuse me, we're going to start up our configuration translator tool. So this will start a REST server inside of the CLI container. Okay, so we've started it up, and now we're going to export the URL for this guy. Okay. And now in this container, we're going to export two other environment variables. We're going to export the channel name, which is the default my channel, and then we're going to export that orderer CA TLS cert, so we don't have to pass in that whole string every time. Okay, so first we'll do that CA cert right here, and then we'll pop out the channel name variable as well. Okay, now we're ready to fetch the configuration block. And this is the interesting stuff that we'll be doing now. Okay, so it's important to note here that we're not fetching the Genesis block. Okay, we're fetching the most recent configuration block. And when we ran through that embedded script that comes loaded with the CLI container and build your first network, we sent two additional update transactions. We updated the anchor peers for each org on our channel. So we really have three configurations. We have our original Genesis block, then we have that second configuration where we defined the org1 anchor peer, and then we have the third configuration where we defined the org2 anchor peer. Okay, so this command right here, it's saying peer channel fetch config. By default, if you don't give it a version, it's going to fetch the most recent configuration block. We're naming it config_block.pb for protobuffer, pointing to the orderer, and then we exported both of these variables right here. Okay. Okay, and you'll see that we received back block 2, right? Just like I said, you have your Genesis, then you have your first update, and then you have your second update, giving us block 0, block 1, and ultimately block 2, the guy that we need. Okay, so now we have this block, and we need to turn it into JSON. We need to decode it into stuff that we can edit, and we're going to leverage this config translator tool in order to do that. So the next command we have is we will send a REST call to that server saying, hey, I want to turn this guy into JSON. So if we look at this command real quickly, we're saying, hey, take this config block protobuf, go to this URL, this REST server endpoint, and I want you to spit me out this right here, config block.json, which is this decoded to this. Okay? So if we look in our container, we see that we have exactly what we expected. This is the guy we fetched, and this is what we converted it to. All right, and now we need to parse this a little further and take the header and some extraneous block data out of it, just so we have the core channel configuration and MSP material. Okay, and we'll do that using our JQ tool. Right. So we are taking config block.json and we're scoping it down to just the config material, and we're calling it config.json. Okay, so if we look again, here's config.json, and these will become very important in a second. Okay, now when we started, and I called this command up here, if you recall, where we printed out the org3 MSP material and called it org3json. This is the material that we want to add back into the configuration of our channel. We essentially want to append this onto the rest of that config.json, that configuration only data that we did right here where we isolated it. Okay, so this command is going to append that org3.json material using the config.json as a baseline. Okay, it's going to add org3 to the application, the group's definition of this channel. All right, it's looking into where we mounted this guy, org3.json, within the channel artifacts, and it's going to print us out another JSON file that's called updated config.json. Okay, so let's take a look at the two guys we have. We have this dude right here, which is really org1 and org2 defined in the scope of the channel. And then we have this dude right here, which is now org1, org2, and org3 all defined within the channel, but without that extraneous stuff, the header material, the wrapper for the block. Okay, so now the next logical thing to do is we need to turn these guys back into protobuffers. Okay, so we'll do that with two very simple commands using that REST server again. We'll take the original guy right here, config.json, and we'll call him config.protobuffer. Then we'll take our updated guy right here, and we will do the exact same thing. Okay, so this seems like like a lot of work, but this is the way that it has to be, and we need to be able to hopscotch back between these two different formats, encode and decode, and that's the really useful thing about this translator tool. So the blocks of interest here are these two guys right here, config.pb and updated config.pb, and what we're really after is the delta in between them. We want all that org3 information defined within a protobuffer. Okay. So we go back here, and the next logical thing, the next step is to use that config translator tool to get us the delta. Okay, so we give this command, and again, it's a REST call to that server, and we're saying, hey, original. Here's my original protobuffer. Here's my updated guy, Mr. Translator tool. Can you calculate the delta and call it this, config update.pb. And I'm well aware that the naming conventions are a little confusing, right? We're just transposing words. But the nice thing is you could name these whatever you want, right? That you don't have to go with this this confusing method of naming. If there's a more logical approach to take, then you can do that. Okay, so now we have this thing config update .protobuffer. And the last steps we need to do is we need to parse that one more time, turn it into JSON, okay, and then we need to wrap all that stuff that we took out. We need to put that header material and turn it back into, put all the contents that the original block had back in it, okay. So now we have this as JSON, right? We had config update.protobuffer, now we have config update.json. So we will wrap it in an envelope, giving us back the header information, as an example, channel header, channel ID, my channel, okay? And we are going to call this config update in envelope.json. I can feel a lot of you rolling your eyes about the naming, but like I said, you can name these whatever you want, okay? And then the last thing we got to do is we need to encode this guy back to proto format, all right? So we will leverage our tool for the final time, and we'll encode him. Okay, so now we got a lot of stuff here, but ultimately we're concerned with this guy right here, this config update in envelope.protobuf. This is what we're going to sign, and this is what we're going to submit to the ordering service to define this org3 on our channel. Okay, so first thing we'll do is we'll just sign as org1 admin. And as I mentioned at the beginning, this CLI container is preloaded with all the org1 material. So I can literally just issue the pure channel sign config transaction, give it the proto that we're signing, and it'll sign as the org1 admin. Okay. Now I need to hopscotch. Now I need to flip to the org2 identity. So I will do that by exporting these 4 environment variables. And this is a common practice. You know, anyone that's gone through BYFN has probably done this if you need to add additional peers to a channel. Okay. And lastly, we'll submit. We don't have to manually sign it again. When we submit, we're gonna get that signature for free. And this is just the pure channel update command. We're passing in our signed proto. We've exported these variables, and this should update the channel with org3 defined. Okay, so it looks like that all worked well. So now we have a channel called My Channel, and it has a new configuration definition that allows org3 to participate. org3 can interact with the ledger. It's defined in the writer's policy of that chain code. Okay, so what's the next thing we need to do? Now we need to go and spin up the org3 Docker Compose. Okay, so if we clear this and type ls, this is the guy that we're after right here, org3 Docker Compose. And this has 2 peers that have been loaded with the crypto material that we generated right away, and then it has a CLI container that is also loaded with the pure 0 material. Okay, so spin this guy up, Docker Compose org3 up. All right, so this guy's spinning. So now we need to hop into the CLI container for our new peer, okay? And that is org3 CLI bash, okay? And again, we're gonna spit those environment variables out so we can just pass them rather than giving the whole string. So again, the CA, so we can verify the TLS handshake and our channel name, okay? Okay. Now here's an important distinction to make. When you join a channel, you have to join with the Genesis block. Your ledger needs to be the same as everyone else's ledger, and the first block on the ledger is the Genesis block. So this peer right here, this identity, he needs to go ask the ordering service. He needs to fetch the Genesis block for this channel. Okay, and we do that. We do that similarly to how we fetch the most recent config block. But you'll notice rather than passing a config value here, we passed pure channel fetch config, we're passing a 0 for the version. We want the earliest version. And again, you can give whatever name you want. I'm going to give my channel.block, and then these are defined. Okay, so that's going to give us back the block right here. My channel.block. Okay. And finally, you may notice all this stuff. You're thinking, why does the org3 CLI container have all this stuff? It has to do with the way we mounted the volumes on the container. All we're concerned with is this guy right here, though. Okay. So now we're going to join our peer to the channel using that block. Okay. So we go peer channel join, pass in the name of the block, and should be good. Okay, and the gossip is going to want us to join our other peer to the channel too, so we'll join peer 1 as well, just to make the logs happy. All right. Okay, so we export that identity, and then we export the address, and we'll join this peer. Okay, and now we can pass that command again. Peer channel join, block, my channel.block, and then these guys up here should quiet down. Okay, they can talk to each other. They can verify that their ledgers are synchronized. Okay, and now we will flip our variables back to peer 0. Okay. Okay. Now we can install some source code. We can install some chain code on the file system. We're going to upgrade the chain code to a different version that defines this organization as part of the endorsement policy. So when I install initially here, I'm going to cheat a little bit and I'm going to give it version 2 because we're going to be upgrading to version 2. So I don't need to go through the extra step of installing version 1 and then installing version 2. So I'll skip right to that point. Okay. So now it's time to install that same version up here on the other CLI container, and then use one of those identities to send the upgrade command for that chain code on our channel. And once we upgrade it and put org3 in the endorsement policy, then this guy will actually be able to issue true invocations. He'll be able to act as an endorser and do writes rather than just commit to the ledger or query. Okay, so this guy's loaded with the org2 MSP material. So we'll just pass that peer chain code install command again, and it will do it for peer 0 of org2. And then we'll overwrite those variables and go back to peer 1, or org1, excuse me. Okay, so we give all these. And then we go look for our install command again. Okay. So now we have this new version 2 of a chain code called mycc installed on peer 0 of org1 and on peer 0 of org2. And now we're ready to upgrade. And this is important. This is where we're going to define org3 inside of the endorsement policy and ultimately allow an org3 member to execute, to endorse. Okay. Again, we're not passing anything of terrible interest here. We've defined all these variables, CA and channel name. We're upgrading with a new version that's of interest. And lastly, we do have to pass the init method on an upgrade. If you code your chain code, your smart contract, to require arguments on init, then you are going to essentially have to reinitialize state. This is not a good practice, right? Our current state is A equals 90, B equals 210. So we have to basically rewrite that to the state database, to the ledger. What we'd really like to do is just pass this init method with no arguments so that our old state can persist rather than rewriting it. This is a bit dangerous, right? I could arbitrarily change the value for certain keys. So just that's a good best practice. Okay. So we send that upgrade call. This will take a little bit of time. This is a true transaction that needs to pass through the ordering service, get validated, and get committed. Okay, looks like that was happy. And now we can come back down here to our org3 CLI container, and we can interact with this guy. Okay, so first we can send a query just to spin a container up. So we'll do that. Again, we've already set these, so we can pass them as variables. We'll query for A, and we just populated the state with 90, so we should see back 90. Okay, and we do. And then lastly, we'll prove that we can really manipulate the state with this guy, and we'll send a invoke and try to give 10 from A to B again. Okay. So common command pure chain code invoke. Sorry about that. And we'll pass our args as A, B, 10, taking 10 from A and giving 10 to B. So B should have 220 and A should have 80 after this one. Okay. And then if we query again on A, we see 80. Okay, so for the time being, that will conclude this demo. We're going to commit some code and add some documentation to this sample, but it's really the process of going through and pulling the most updated config, parsing that to get it to JSON, then isolating the config-specific information, right? Appending whatever you want for your new org and/or orgs to that, right? Now you have two different JSON files, so you encode both of those, calculate the delta, decode, wrap it, encode, sign it, and submit it. So it seems like a bit of an arduous process, and it is quite involved, but there's method to the madness, and hopefully this video shed a little light on how to go through this process and how to succeed. So for the time being, that will conclude this. Feel free to use Rocket Chat and the message boards to ascertain some additional details. Okay, thank you for watching, and good luck with your configuration updates.